Hi, this is Kevin Trainer, and I'd like to welcome you to my lecture on validating XML documents with DTDs. And in particular, in this portion of the lecture, we're going to cover DTDs for the style of XML documents that are popular for data interchange. So what we're going to do is we're going to take an example that we developed a couple of lessons ago when we were designing and authoring an XML document for data interchange. And we put together an employee list and we built it up kind of step by step. And here's what we're going to do now. We are going to build it up the same way, but have a schema for the document that is based on a DTD, and we're going to build that schema up in the same steps. Okay? So here on slide number 91, you can see the first step of an internal DTD. So this is actually one file, one document that includes both the DTD and the XML document itself. So you may remember from the example that we did before, we began with a very simple XML document, just has one element, the name element, and we have the name content, the text content inside, Xavier Ampel III. And for those of you who don't appreciate my humor, I just want to point out that Xavier Ampel would be example III. If you can't appreciate a good XML joke, you're probably in the wrong spot. And then up on top of that, we have the doc type, which points to a DTD, and the DTD text is just one line. We can see it begins with a less than exclamation element. So it has an element declaration for an element with a name of name. And then it has a content specification, which is pretty simple. It's a standard one, #PC data. So let's look at our comments on this slide. So while we don't have to have a schema for XML document, there's a benefit to having one. And the original schema capability for XML documents was called DTD, Document Type Definition. So DTDs are kind of schema for XML documents. Schemas define which elements and attributes can occur within the XML document and in what order they must occur. When we author an XML document that is coordinated with a particular schema, we call that an XML instance document because it's an instance of that document type, the document type being defined by the DTD or schema. And we bind the XML document to the DTD via a statement that we saw a few seconds ago called the doc type declaration, which we had up in the top of the XML document. One of the things that you need to do in a doc type declaration is you must identify the root element that will be used within the document. And the reason for that, as we'll learn soon, is that in the DTD language, you don't specify any particular element as the root. And so in order for a parser to validate our document, it has to know what should be the root. So we have to add that information when we code the doc type. And doc type declaration must either contain or point to the text of the DTD. This example that we're using right now is internal, so the doc type is it contains the text of the DTD, but in the next iteration, we're going to use an external DTD, so we're going to go from having just one file to having two. The DTD language is not written in XML itself, so it's not an XML tag set, it's not an XML application. It's written in its own little language that we call the DTD language. So in this example that we have so far, of course, we only have a single element type. So we only have a single element declaration, and it specifies a content model, which is the rules for what content can appear in the element. And that is really the simplest of the models that we can have. #PC data, all caps, and that stands for parse character data, and you can interpret that to mean plain old XML text. Instance documents that conform to their schema are said to be valid. And previously in this course, if you're following a tutorial, the first of the tutorials that we did, we created an XHTML document, and it had a doc type that pointed to the standard, or one of the standard DTDs for XHTML, and because of that, we were able to validate our XHTML document on the basis of that schema. Well, we're going to be able to do that for these more content-oriented XML documents as well. Now, an XML document can be checked for validity using a validating parser. And these days, most parsers are validating parsers. When they came up with the XML standard, they wanted to make sure that it was as easy as possible for people to go ahead and build XML tools. So they came up with two categories of parser, validating and non-validating. And at this point, XML being a fairly mature technology, the parsers that have survived are the validating parsers. There are parsers that are used in very limited applications, like in very small computers that could be non-validating, but that's not typical. So here's the slide number 94 that's a little bit outdated. When I first taught my XML courses back starting in 2004, I would have my students, when we were doing the lab portion, I'd have them work with an XML editor called XML Spy, which is still a great product. These days I have them work with Oxygen XML. In either case, an XML-aware parser is going to have a validate function. At least in the old days in XML Spy, one of the ways you could get it to validate your document when you're on the XML document was to press F8. I think there was also a button icon. In Oxygen XML, there is a button, a red check mark these days, and when you click on it, it runs validation. Okay. And I just want to say that because of the rules of how XML works, if you check a document for validity, by implication, you're also checking it for well-formedness. You'll remember that well-formedness is conformance to the syntax rules of XML, and the rules for creating parsers for XML say if a document is not well-formed, parsers are not allowed to go on and do further processing, in particular validity checking. And so if you validate a document and it's not well-formed, well, you'll get a complaint on well-formedness, and you won't even be told that it's not valid because, well, it may look like it's not valid, but technically it's not well-formed because you can only check validity once you have a well-formed XML document. Okay, here we are on iteration 2, and hopefully you remember this from when we were going about the authoring of our document a couple of chapters ago. And so what we're doing here is that we are taking the document. We had one element called name, and we think that's a great idea, but instead of just typing in the text for the name, we want to mark up the first name, the last name, and the suffix so that we're able to find those and process individually. So we have 3 child elements under name: first name, last name, and suffix. And you can see that the doc type is a little more compact because it doesn't include the text of the DTD. It simply includes a pointer to a file that holds the DTD. And because we don't see any path expression in the beginning of the file name, we know that we're expecting the DTD to be in the same directory as the XML document. And the keyword here that says that it's an external DTD and not internal to the XML document is this keyword system. So this says, oh, that's an external DTD. You go get it from the system, and where. Now this could be any URL. So it could just say HTTP, blah, 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 blah. And in fact, way back when a little bit earlier in the course, when we created an XHTML document, we used the same syntax, and we pointed across the net using a URL to the DTD for that particular version of XHTML. Now, something that I hadn't said previously, but is an important point, I've been saying that you have to say in the doc type, what is the name of the root element? And of course, it's a little bit confusing here, but the name of the root element here is name, N-A-M-E. So these have to agree. So the name that you put here has to appear in the DTD. And of course, it has to be the root, has to be the name of the root element within the document itself. If you don't get all those things to agree, you're not going to have a valid document. And let's look at the DTD. So now we've gone from just one line of declaration to 4. And so the last 3 are pretty easy to understand because these say that we're expecting to have an element. One's called first name, one's called last name, one's called suffix. And the content model is specified in the parens, and you can say it says # PC data. And you may recall that it simply means that this is going to be plain old XML text. Okay, no sub-elements, just typed in text. Okay, now the first line within the content that's in the DTD is different because we say that the element is name, which we had before, but now we're going to say it's more complex, where the content specification is again inside the parentheses, but we have first name, comma, last name, comma, suffix. So what we're essentially saying is that name has 3 child elements: first name, last name, and suffix. And as we'll see when we get to the comment slide, we're claiming that they always occur in the document, and they always occur in exactly this order. Okay, and if we back up, we'll see that in our one instance of this type of document, we follow those rules. We do have a first name, we do have a last name, and we do have a suffix, and they've occurred, and they've occurred in that order. So let's go on to the comments. So this example 4.2 uses an external DTD. External DTDs exist in a separate file pointed to by the doc type declaration. The way to specify a content model for an element with children is within the parens child 1, comma, child 2, comma, ... comma, child n. So as many children as you're going to have, you can string them together with commas. If we just string them together with commas and don't add any other notation, we're saying that the children must always appear, and the children must always appear in this order. We have to remember, and this is a place where I still get caught from time to time when using DTDs, you have to remember that in addition to listing a child in the content model, the child element must have its own element declaration. So if we back up here and look at the preceding slide, we'll see when we declare name, we say what the content model is for name: first name, last name, and suffix. And it's not enough to just identify them there. They each have to have an element declaration. And if I hit a quarter for every time I forgot to put the element declaration there, I'd probably have a lot of money. So, and I suspect that that may happen to you too. So that's a good place to look for careless errors if you're having a problem. Okay, so now we're going to go on to the third iteration, which is where we begin to add optional and repeating elements to the XML document. And those are going to be, we're going to start to treat some of the sub-elements for names optionally. Okay, something like suffix. Not everybody has a suffix like the third in their name. And in the address, you can see here, we have 2 occurrences of the element street. Okay, and this is a pretty typical way that we represent an address in an XML document. Okay, in some other technologies, we would say street 1 and street 2, or street 1, street 2, street 3, street 4. The problem with that is you always have a field street 1, street 2, street 3, street 4, and of course, typically 2, 3, and 4 are empty. Here, we're going to say, well, you can have more than one occurrence of street, okay? And the way that you can tell them apart is just by the order that they occur in. But if we only have one, we're just only going to have, one street element in the XML document. And we'll talk about that some more a little bit later. So here on slide number 99 is the DTD for this iteration. Um, and we've gone a little bit further. We did make another change to the document. Let me back up. We made the root element employee, okay? Because we didn't just want a name. We wanted a name and an address. So now we're enclosing the whole document in employee. So you can see that we've added that as the enclosing root or document element. You can also see up on the doc type that when we did that, we had to change where we had said previously that the root was going to be called name. Now we're saying that has to be called employee. So we start off by adding in employee. We have an element declaration for the employee element. And I've put it first. And what I usually do is I usually put these declarations kind of in the hierarchical order in which they occur in the document. The language is very flexible. You don't have to put them in any particular order. You could shuffle them like a deck of cards, and they would still do the job as a DTD, but it'd be very hard to maintain. So what I try to do is I try to put the definitions in, or the declarations in. I try to put them in some kind of an order that mimics what the XML document is going to look like structurally. So when you go to look for the declaration that you want, you're going to find it without a lot of trouble. And I consider this to be a pretty good practice. So we begin with the new declaration of employee, and we say that every employee, the content model is it always has a name and then it always has an address. So I need to declare name and address. Well, I already had name, right? But now I'm going to make it a little more complex. In the content model for name, I've said that suffix, I put a question mark after the word suffix to indicate that it's optional. It might occur, it might not occur. And now I've also declared a middle init element as well, and we put a question mark after that to say that it's optional too. And you'll notice that I have the declarations immediately following for first name, middle init, last name, and suffix. And because each of those is just plain old typed in XML text, when they occur, they all get the content model of #PC data. So even though from time to time I forget to add these kind of lines, it's pretty easy to make them because I clone one into the next, because they pretty much are all the same except for the name. And now you'll see below that group, we have the declarations for address, and the declaration for the address element itself, the content model says street plus, that's a little different, than city, state, and zip. So city, state, and zip are typical. They are all going to occur. They're all going to occur every time. They're all going to occur in that order, and there's going to be one of them. What about street plus? Street plus says I have at least one, and I may have more than one. And in the DTD language, as soon as you say there's going to be more than one, there's no way in the DTD version of the schema to say that you're going to have a number that's limited. So you can't say you're going to have at least one and at most three. When we learn about the W3C XML schema, which we'll be doing a lesson or two down the road, we're going to learn that we have the option of saying we have from 1 to 3 occurrences of the element street. But we can't do that with the DTD, and that just has to do with history DTDs and what they originally were used for. They originally were used for publishing documents, not so much for data interchange. And so in publishing documents, saying that there are, from 1 to 3 paragraphs, really doesn't have a great usefulness. If you're writing a chapter, you're probably going to have from 1 to n paragraphs, right? Well, that's the reason why if you say that something it can occur more than once, we don't limit the number of times that it can occur. If you really want to worry about that, well then you're going to have to hang on for the W3C XML schemas. Okay, and some comments around this example 4.3. When we look at the text inside of the DTD itself, there isn't any one of the declarations that says, oh, and by the way, I'm the root. Okay? So because of that, the doc type has to say which element is the root. So because we changed the root from name to employee, we had to change the doc type. If we back up here, on the doc type on slide number 98, you can see that we have changed from name to employee as the name of the root element. The content model for an optional element is to use the element name and follow it immediately by a question mark. If you can have so that says you can have either 0 or 1. You can't have 2, okay? And they have to be exactly in the order where you say. So wherever that occurs in the content model of the element that you're declaring, it's going to occur in that place, and there's either going to be 0 or there's going to be 1. It's optional. The next one, which we call optional and repeating, uses the asterisk, and that says it's going to occur in that location. There's going to be perhaps 0 and perhaps 1 and perhaps more than 1. So from 0 to many. That's what we mean when we put the asterisk there. And then last, we have the plus that says it's required. There's always at least 1, and there may be more. So 1 or more. Okay? So if we just back up and look at what we did for street, you'll see that we use the plus because we're going to have at least 1 line of street address. Whereas up in the name, we have middle init and suffix. We use question mark because those are optional, at least in most American names. Okay. Now, what if we wanted to have a content model that's a little different? Well, we're gonna learn about those as we go. But what if you wanted to say that you could have an element 1 here, or an element 2, or an element blah blah blah, or an element n? How would you do that? You would do this with these selection symbols. Some people call them a bar. I usually call them the OR bar because they're used for logical OR in some programming languages. People who come from Unix and Linux call it the pipe symbol. But here it's the symbol that's in between element 1 and element 2 in the first bullet point. So what we're essentially saying is that there's a selection that's going to be made from the list, element 1, element 2, as many things we have in the list. So there's going to be 1, and it's going to be one of these. There are times when it makes sense for the content model of an element to be empty. You probably remember that in XHTML, the break element never encloses any text. So we usually code it as a BR/, right? Well, how do you tell the DTD that we want the break element to be empty? In the parentheses where we specify the content model, we simply use the word empty. There is the possibility of a really flexible kind of approach using the keyword any, but typically we only use that when we're developing DTDs, and I don't think it's a strong habit. So I'm not really going to talk about that any further, but you might want to read about that if you think you're interested. There's no way to constrain the value of element text using a DTD. So inside the element text, you can type whatever you want, because typically we're saying #PC data. That means any old thing that you can type that's legal in XML. So you can't type an unescaped ampersand, you can't type an unescaped less than, but apart from that, you can type, to your heart's content. Okay, now we're just going to go through the next iteration, example 4.4, and we're going to add the XML declaration to the document, and we're going to add the phone element to the document. So if you look up top, we've added an XML declaration. It goes in front of the doc type. So the XML declaration is the first line of the file. Then the doc type is the next line. Okay. And you'll see if we want to add a phone, we're just essentially adding another child element to employee. And it'll be interesting to see when we get to the next page, the next slide, 103, what was the content model that we use for employee that says how many phones we're going to have. Let's look. So we can see that here on slide 103, we have a declaration of the element employee. We say we're always going to have a name. We're always going to have an address. We can have 0 to many phones. So according to the rules that we put into our DTD schema, we are saying that we don't have to have a phone, and we can have one or as many phones as we would like. Okay? If you look at the declaration we have for name, that hasn't changed. If you look at the declaration we have for address, that hasn't changed. But we do have a declaration for the phone element itself. And for right now, we're just saying it's PC data. So we could type just about anything in there except characters that need to be escaped. So a few comments about these. The XML declaration has no counterpart in the DTD. Okay, it's kind of transparent to the schema. And so if your document has an XML declaration, that's good. If not, that's good too. The DTD doesn't interact with it. And we always have to remember to give repeating elements like phone the proper content model, even if they don't repeat in this particular instance document. And this is when you're trying to design a document with an example document, it's usually helpful to have enough examples so that you can tell and you can test out whether the rule that you've used for phone is the right one, right? So we've said that we're going to have 0 to many of them, and we happen to have 1. And so if we go to validate it, it's going to pass. But of course, we haven't really fully tested it. To fully test it, we would have to maybe take out the phone and see if it would validate. And of course, it should, right? So a little testing goes a long way. So we're continuing to develop this example. And here we've gone so far as to create the full employee list. So we're keeping the XML declaration. We're keeping the doc type. And if you notice, what I've been doing is every time I change the example, I change the DTD. So the DTD file that we're pointing to is a new DTD file, which of course has the new statements in it. So we've also changed the root element name, because instead of having just a single employee, we're now conceiving of this XML document as an employee list. So the root element name is employee list, and you see that appearing on the doc type. Now that's a place where it's easy to make a mistake when you start to enhance a document and you change the name of the root element. It's not uncommon to forget to change it on the doc type. So you're trying to validate this, and on the doc type we still say employee, and now the root is really employee list, and it doesn't validate. Oops, had to change it to employee list. So the first employee is pretty much the employee we've seen before, Xavier Ampol III. He's got 1 phone number. Now on slide 106, we see the second employee, Frances R. Smith. She's got 2 phone numbers. And then at the bottom of slide 106, we get to Raymond Jones. And on slide number 107, we say that he has a single phone. So I just want to point out that we still haven't really tested whether you can have an employee that doesn't have a phone. We know the rule we put in the DTD should support that, but we haven't tested it by trying to validate a sample document that has an example of employee that doesn't have a phone. So for it to be fully tested, we would want to probably throw in a third employee, a fourth employee that had no phone. And what I usually do when I'm doing this kind of work is I do a lot of copy paste. I'll take the third employee, I'll copy it over, I'll change the name, I'll change the address, I'll get rid of the phone, and then I'll try to validate it. And then I'll have a proper test right there. So here's the DTD that goes with this iteration, okay? So at the very top, I've put the declaration for employee list. And remember, these can be in any order. You know, we could take them and shuffle them as for what the rules are for the technology. But the order that we have them in here is, I think, a best practice. So I'm really going to recommend that you do that. So we're saying the only rule for employee list is it has to have 0 or more employees. Now, this is an interesting question because you really have to ask yourself, should I say 1 or more employees, in which case I would have employee plus instead of employee asterisk? I usually like the 0 because at some point, it's possible for us to have a document, say for a region or office we haven't staffed, and we don't have any employees, okay? And that's a fact. I mean, it's a very trivial fact, but it's a fact. So I would like to be able to have an empty employee list. So that's the reason that I've used the asterisk there instead of the plus. We haven't changed the definition, the declaration for employee, or for name, or for address, or for phone. So those were all pretty straightforward. So a couple of comments. Always remember to put the proper root element name on the doc type. Make sure to include enough content in your instance document to fully test your DTD. Okay, now if you've been following along kind of chapter after chapter, you'll know that this is the point with our example that we add attributes. So we haven't really put content into attributes yet. And as you can see here, we haven't changed much except that if you go down to the first phone, which is the phone for Xavier Ample III, on the start tag for the phone element, we have the attribute type with a value of home, H-O-M-E. Okay, and now we're going to go down to the second slide, number 111, and we see that for Frances R. Smith, her first phone is type home and her second phone is type mobile. And then if we go to the next slide, we see that for Raymond R. Jones, his one phone is a mobile. Okay, so how does this get reflected in the DTD? Well, the DTD has pretty strong support for attributes. So let's look. So here on slide 113, we see that the beginning of the DTD hasn't changed. The element declarations starting with employee list down through employee and name and the group under it and address and the group under it and phone, they're all the same. But at the very end of the slide here, we see that we have an at list. So we have declared an at list for phone. So this is how we say that the phone element can have a list of attributes. We call it a list because the declaration can declare more than one attribute for phone. Okay? So we say at list phone, that's what associates the attribute list with the element declaration for phone. And then you'll see that we have one line that comes after that in which we say type, happens to be the name of the attribute, C data, which is a lot like # PC data. It's the way that we say that the text that's inside the attribute is going to be plain old XML text. And then we have # implied, and that is claiming that the attribute is optional. So we might have a type attribute, we might not, because at this point in the development of the DTD, we're going to change it in the next iteration, but at this point it's optional. Okay, so let's just go look at the comments we have about this, this round of changes. Attributes are added to the DTD using the @list declaration. Multiple attributes can be added to an element with a single @list declaration. And I don't know whether you can have more than one @list for the same element declaration, but it certainly would be bad practice and style. The DTD language allows for liberal use of line continuations. Okay? And I just want to point out that we used a continuation. If we go back here and we look on the bottom of slide number 113, we began the atlas and we just put the word phone there to say, okay, this is the elements it's associated with. And then typically what we do is at each attribute that we have, we put the data associated with it, which are 3 values that we see here. we put them each on their own line. And then, of course, on the last line, we close with the greater than sign. So here we've only used a single continuation. Now, do you have to put them in this order? No. Is it a good practice? Yes. Do all the good people do it? Yes. Okay. So the DTD language allows for liberal use of line continuations, and we usually take advantage of that when we code an @list. The DTD language allows for declarations occurring in any order. So the @list could have been anywhere. We put it after the declaration of the element that the @list is for. That works. It would work if it was in before it, actually, but that wouldn't be good practice. So the place where we put it is a great place to put it in terms of practice. Specifying the attribute type of C data allows any type of XML character content. And again, the only thing you have to remember here is that if you want to use the ampersand, you have to escape it. If you want to use the less than, you have to escape it. You cannot mark up the values of attributes. You can't have an attribute value that's got a tag that has got element tags in it. That's not allowed. And specifying # implied makes the attribute optional. There is a way of thinking that I could talk about is why it being implied makes it optional. But I think it's just a particularly bad choice of word that has to do with the fact that this DTD language was appropriated from SGML, and implied had a more sophisticated meaning in SGML, and here it means simply optional. Okay, here we are at the last iteration of the changes that we're going to be making to the XML document and to the DTD. So you will remember that in this iteration, we've added a comment. The contents of this document are confidential, etc. We've added 2 more child elements of employee list date, and list region. Okay. And the rest of the document, I think, is pretty much the same. So let's look at what happens to the DTD. You'll notice here that the other thing we've done is to change the rules for the attributes for phone. We wanted to make it a required attribute, and we also have the ability to control the values that are coded for the attribute, and we've taken advantage of that too, although that's on the next slide. So you will notice that we've changed the declaration for employee list to include list date and list region, as well as employee asterisk. So we have to remember to have a declaration for list date and a declaration for list region. The declaration for employee has not changed. The declaration for name and address have not changed. The declaration for the phone element itself has not changed. But as we go to the next slide, you're going to see that we have another approach to how to code the attribute list. And here's how to read what we have. We have a type attribute, and then in the parentheses, separated by the bars or the pipes, we have choices of valid values for this attribute. So the type attribute can equal home or office or mobile or fax, and only them. If it says anything else, if it's blank, if it says home X, if it says mobile 2, not valid. Okay. And the other thing that we've done is to show you how you make an attribute required, which is with the keyword # required. Okay. So, a couple of comments on this. When adding an element to the DTD, remember to both add it to the content specification of the parent and to declare and to include an element declaration for the child. This choice of values is called an enumeration. So we can use an enumeration to constrain the valid values of an attribute. The syntax for an enumeration is the syntax that we see that's surrounded by parens, and we separate each valid value with the vertical line or the pipe character. Specifying # required makes this attribute mandatory. Remember to create versions of the instance document that tests for a missing attribute or invalid attribute values. So for instance, if I were coding that this is a required attribute for type, I would want to put a phone element in, leave the type attribute off, and make sure that it doesn't validate. Make sure it comes up invalid. Likewise, I'd like to see an example of home, mobile, and office and make sure all three of those come up valid. And I'd like to see maybe an empty one or some, random text, and I'd like to see those come up invalid. So you're going to want to make sure that you test these rules to make sure that they are as we expect. So that's it. We have developed a typical data interchange XML document and a DTD to accompany it. And I'll give you that to play with, and I'll look forward to seeing you next time. Bye-bye.